All right, lady, what is this?
Welcome to Show and Tell.
Live from Brooklyn.
Live from Brooklyn. It's me, Lady Ada. With me is Mr. Lady Ada. I'm going to check in with people from around the Adafruit and making community. What are they hacking, coding, soldering, synthesizing, emulating, whatever they're doing? We want to know it. We want to see it. We're in Discord. Come on by. All you need is a video camera, an internet connection, and something that you made. Doesn't have to use Adafruit parts. So let's check in with some people from the Adafruit community. Yeah. What is the team hacking on?
This is your chance to see some behind the scenes at Adafruit and more. Lots of top secret new releases. We do this every single Wednesday, 7:30 p.m. Eastern time to kick it off this week. Scott, does it matter?
Something does.
Yeah.
As we were talking about earlier. Yeah, so I've been working on the Matter spec. It's supposed to be the end-all be-all of IoT specs. As we were talking about earlier, there's a lot of confusing terms around there.
Yeah.
I'm in particular working on the protocol itself over the network. I'm not doing any transports or anything. And I've been trying to get Python code that acts as a light bulb, so on and off from Python. So I showed it last week that I was doing all of the commissioning stuff, and I've actually got commissioning working, and I can save the info. So what I'm starting here, I'm just going to run it, and it's not going to show me the QR code anymore because it's remembered my info. And now in my home app, there's a Scott.Matter device here, and if I tap it, it turns on, and then on the console we can see the on exclamation point. There, and if I tap it goes off.
Ooh, that's
yeah. I'm troubleshooting an Eve motion sensor and door sensor, and I don't have a terminal to see what's going on, and I'm just like and so this is really handy. You can actually see what's happening, and it's showing up on your home screen.
Yeah.
Or the home app. Sorry. Yeah.
Yep. So on the home app, I'm now remembering the commissioning info for it. My next step here, as you know, I'm about to have a baby, so who knows when I'll disappear, but I'm hoping to get, I was thinking I'll shoot for a Raspberry Pi 2.0 or 2 plus, 2W.
Yeah.
Mixing all my numbers. Pi 02W as a NeoPixel light, and if I can get that going on and off, and Scott.Matter packaged with some really easy Scott.Matter plus Blinka code to do it on and off, I'd be pretty excited.
Yeah. So for folks who are kind of just tuning into this, one of the challenges is even though this is supposed to work across multiple home automation systems like Alexa and it still is really, really hard. And then in the microcontroller world, each microcontroller company is kind of trying to make their own kingdom, so you use their own tool sets and SDKs. So we're doing what I think we do best is making something that'll just work with anything you have. So from Arduino to ESP32 world to Nordic stuff, you'll just be able to use CircuitPython and be able to do I just want to turn a light on and off and cool. And you don't have to join a specific hardware platform forever. I was also joking in our meeting before this, I was doing some research. It reminds me of batteries for power tools. Once you're in the DeWalt world, that's it. It's over forever. And it'll be
our
interesting.
world's the Python world.
Yeah, but
we've shown that our drivers are portable and everything.
Yeah, and I think people are going to appreciate that because if you're setting up your home, it might be there for a really long time. I've been using the Philips Hue lights for 10 years, and they almost were going to change something significant, and everyone just freaked out and they're like, okay, fine, move on. But anyways, all right, cool. So you're going to show some of this off on Deep Dive this week?
Yep, that's the plan. Hoping tomorrow's Raspberry Pi Day, so maybe I'll have it actually controlling some NeoPixels by Friday.
Okay, good luck.
I think I've got all the pieces. Just maybe have to massage them a little bit and getting it all packaged up.
Yeah, maybe we'll do an explainer too, Threads, Matter, HomeKit.
Yeah.
Google Home. Alexa. Okay.
Yeah.
Alrighty.
Yep.
See you this Friday.
Thank you.
All right, Ian, what you got?
Hi, everybody. I was putting together a few things I had. I really wanted to use the new Feather RP2040, and I was thinking about what other parts and gizmos I have in here, and I remembered I bought a solder party keyboard FeatheWing. So it looks kind of like BlackBerry, and it has a screen, a keyboard, and a couple other parts, and it has a neat feather socket on the back, so you can plug in whatever feather you want. So I don't know. I've got another camera. Can you switch, or do I have to switch? Or
well, you do something, and I'll tell you if it comes up as another screen or if it's you. Yeah, you're good.
Okay. There's a little close up. What I did was I needed some software. Once I got the Feather loaded with the latest CircuitPython. I turned on the NeoPixel. That will probably blow out your eyes. I apologize. And what I found when I was looking for software was you didn't necessarily have to write my own. It just depended on what I wanted to do. There is a Linux-like environment that's built on top of CircuitPython. It's now called Beryllium OS. But I saw this other one made by a CircuitPythonista called Retired Wizard. And it emulates, it doesn't perfectly emulate, but it's a MS-DOS-like environment. So if I grab this and type dir for directory, it does a listing of all the files on the system. And it has, it can run PyBasic, it can run the CircuitPython REPL. It can do quite a bit of stuff. So I've just been trying to see if I could play with it. I also found a little layer case that I threw on my new 3D printer. And so I've got something to kind of hold on to it. There was another layer that added, these seem to be really popular for putting a mesh-tastic radio on there, and use something like this for that. But I was more into retro gear, so this is what I built, and kind of having fun with it.
Pretty cool. Alrighty, well, keep coming back and showing this, and if you find anything really interesting that's worthy of a guide.
Oh, I did write it up. It's not guide. It's a learning system playground. There's a note. If you go to adafruit-playground.com, I believe that's the URL, and check it out. It's called a PyDOS handheld. It shows all the stuff I made and pointers to all the files. It's all open source, and have fun with it.
All right, thanks so much. And next up, Liz, what you got going on this week?
Hey, so last week for JP's product pick of the week, he used the CH32V203 Cutie Pie. And it reminded me that I had wanted to try playing around with it more after I did the product guide. So I dug out an e-ink display and iSpy BFF, and it worked. And so then for a quick guide, I added a real-time clock over Stemma, and I have a little daily calendar and clock. So just kind of like a quick demo for using this Cutie Pie, because you can use Arduino. There's tiny USB support. So definitely some opportunities for some cool projects, and it works with the BFFs. And one thing when I was working on this, I wanted this to be kind of a quick project. So I sat down to Fusion to do the enclosure. I didn't want to do a box, but then it was like, how was I going to enclose the BFF and the Cutie Pie? And what I came up with was this kind of little hook thing, so that the BFF and the Cutie Pie sandwich over it, and
that's a good idea.
A little hug.
Yeah. So this guide is up on learn.adafruit.com now if folks want to check it out. And we also have the product guide too for the Cutie Pie. People want to play around with it.
All right, very cool project. I like that someone gets started right away, and it's a useful thing too.
Yes, yeah.
Hello world for calendars. All right, thank you, Liz.
Have a good one.
Next, Jeff, I saw the preview of this. This is
Hi there. Yeah, so I took a couple weeks off to make kind of an old style terminal. And this is for my friend Chris, who does a lot with retro computers. So down here you can see I've got the frame rate's not so great, is it? The RP2040, a connector for old school AT keyboard, and a VGA breakout, and it's creating a 2-bit video signal. There are 2 resistors here. It's hard to see these 2 little blue guys. So right now it's hooked up to my Linux computer over there, and it says GNU Linux. Hit enter to log in. So let's do that. You can run all your favorite programs like NeoFetch to print a little Debian logo in the terminal. You can run top and kill some processes. Or most important, you can join the ASCII version of Star Wars in progress. What's going on here? I'm not sure what scene we're in.
You got bold characters going on with the 2 bits. As it gets it activates the phosphor a little bit more.
Mm-hmm. Yeah, so it's actually creating 4 different analog levels by having 2 bits of output. Oh, that was the end of Star Wars. A lot of similar projects I've seen, they just have black and white. So this goes a little bit further and provides you with 3 levels of gray. So you got your bold, you got your regular, and your dark.
Okay.
This is great. I'm doing our floppy museum at Adafruit, and there's also some old monitors, and like some of the stuff, I don't want to throw out, but I also know that the computers, the old retro computers might not work. Maybe the monitors work. There's a whole combination of things that work or don't work, but this is really neat because there's a chance that these will avoid the landfill or,
right,
recycling. Mm-hmm. So this is really neat. Where could folks find out more about this if they want to?
So on our Discord, I've got some links to the GitHub project, and I also gave a quick link to the VT100 escape code library that I incorporated, because that was like a big part of the software is handling those escape codes that every Linux program thinks it's going to send. And I guess I've been talking about doing this with Linux, but the idea is that you would use this with a retro computer. So it can take anything that's like a TTL level serial, or you could convert an RS-232 voltage with one of those little boards that does it. So this is really for retro computers, but what I had to show here was Linux. It's kind of cool to log into your Linux computer old style too.
Yeah, it's so neat. There's a different glow to the screen too. It's like, I'm back home.
Yeah, I mean, I used to use every computer this way, and finally I gave up, and I open up a windowing system.
Yeah.
This feels nostalgic.
And it goes gazorg. There's like, it's kind of like when people like vinyl records, because there's like skips and scratches. Like if your MacBook makes a sound when you turn it on, you're taking it to the Genius Bar. Like, besides if it started going like gazorg and like slowly warmed up, you'd be like, I got to return it. All right, thanks so much.
Thank you. See you around.
Yeah, we're gonna play the video on Ask an Engineer for
awesome.
One of the sections in there. All right, thanks.
All right, thanks, Jeff.
All right, next up, Dan, and then Mark. Dan, what you got going on?
I wanted to keep this quick because it's a mess in progress. I decided to mix some things up and made some hardware. So I have somewhere back there. There they are, sitting next to the meter. A pile of stuff from you and Spark phones, some antennas, and all the parts to make this thing happen.
Okay.
So the parts. Parts. All right. So what this is, it's an ESP-based, ESP32-based controller. All right. It uses your, let's see here, stemma analog connectors and the I2C connectors, and I hooked it up with servos as well. And it's reconfigurable. Other side, reconfigurable, transmit or receive. So this could be. You use these for potentiometer inputs, right? It'll power them. Obviously, very different configuration than powering it off a speed controller, which is how most remote control systems work. What this is a low-cost flight controller. It has all the essential elements you would need to do your own drone with GPS, with inertia measurement unit, with lots.
Yeah.
So, and that's kind of what's going on there.
Cool.
The hardware's back. The software is not even close to done.
That's okay. You got something to play with. It's good for it's cold out. Stay indoors. Work on your drone.
I'm in Florida. No, Space Coast. I mean, I guess cold here. Yeah, it's like
stay inside and avoid the hurricanes.
Get ready for the hurricane next week. This is really neat. And I also like your tagline, "A mess in progress." I think we should use that for multiple efforts, because enjoy the mess. It is. This is the best part of making, because you're able to. Yeah, you're breaking no rules, because there are no rules for something like this. You're making your own thing. Scott, who got his start with Adafruit, for coming on the show until he did Chickadee Electronics, and he was making like drone modules and all these things. Hard to do it as a business, but very fun to do it as a hobby. So.
Okay.
All right. Thanks so much, Dan.
Sweet. Thanks, Dan.
Yeah.
All right.
Keep coming by as you get more done.
Yeah, absolutely.
I want to see the mess.
Yeah. A mess
progress.
in progress.
All right.
Yeah. Sounds like it sounds like America. We are a mess in progress. Okay. We're the best mess. Mark, what you got going on?
Hi. So I finally got merged in the start of audio effects. So after I remembered how to hook up my keyboard, let's hope everything works. So I'm hoping you guys can hear that.
Yeah.
So it's now in. For anyone that hasn't seen it, you can adjust a whole bunch of different things. There's the delay, so from very slow up. Right now, I've just got it configured up to a second, but it could be basically you're limited on memory. Down all the way, and as it's playing, you can actually adjust it. And let me just crank this up so it plays a little bit longer. So you can actually hear the change as you're going. And then, unfortunately, I had no decay on the echo, so we might get some artifacting. But right now, you can do pretty much anything you want in terms of changing all the between the delay, the decay. There's a mix control, so that alters between how much of the original sample from the keyboard you're getting to just the sample itself to just the effect itself.
It's like the beginning of a 70s mystery sitcom or something.
Yeah, I just picked an echo to start because it's something I understood.
Yeah.
I have to give a lot of credit to Cooper, who has been on the Adafruit Discord and on GitHub, and he actually provided a slight variation. So in his, it'll actually frequently shift as you change the echo delay. So you get that Doppler effect. So same basic effect, two different ways to do it. So this is in the main branch of CircuitPython right now, not in the latest build. So my plan is to still work on this more. I needed a definite brain break from all this. And I've already found one defect in it I have to submit a PR for today or tomorrow because that got missed in the end. But yeah, the idea is that there's a template now that I want to add some other effects, but then if other people want to, hopefully the path is much simpler to add more, to do basically whatever.
Yeah, what's neat is people can make custom hardware that works with this. You can use existing all sorts.
Yeah, this is running on a 2350 right now. It seems to run fine. You could actually chain these effects together. You could to make other new effects. So you can have your echo go to your echo.
Yeah.
That's the only effect right now. But as there's more, hopefully you're able to have your chorus effect go into your reverb that has a delay and whatever audio engineers like doing. I'm not one, so some of this has been a great learning experience for me.
Yeah, I think saw an interview with I want to say it was Rick Rubin. I think he was talking about someone else, and it was like, sure, you can. I'm just summarizing probably what I heard right before I fell asleep or something like that watching this. But it's like, sure, you can do everything in a computer interface, like never have any hardware at all whatsoever, like just look at a screen. But there's magic in the wires, something about doing these things where you're chaining it together and I think there's something special about making your own musical instruments because you're always looking for a unique sound that you understand and you want to get out of your head. And just doing this, virtually, I guess it's okay because you could always get plugins for whatever music thing. But I've just noticed, like, even though you can do that, more people like building their own instruments in some way. And so this is really neat that you're making this tool for people to do all sorts of stuff, because I think I think it is true. There's something, the sum is greater than the parts when it comes to these things.
Yeah, thanks. And it's just interesting because then you get to see how your own instrument's working. Like, I knew vaguely how a synth works before, but until I've done this, now I'm like, oh, okay, that's how all these parts, this is what all these different effects do. What is a reverb? Like, I know in theory, but now the math behind it, it's like, oh, okay.
Yeah, this would be a neat thing for like young people. Like, you build your own synth, and all along you're learning the math and all the things to get there. But you're kind of getting tricked because you're like figuring out this stuff. Like, what is echo really? All right.
And with CircuitPython, it's great because just as always, testing it in the REPL, you can just quickly iterate through it.
Yeah.
And then bring out the keyboard like this when you're done.
Yeah, life should have a REPL. All right. Well, thanks so much, Mark.
Thanks a lot.
Okay, that's our show and tell. Thank you so much, everybody, for joining us. We're here every single week, 7:30 p.m. Eastern time. That's where people show and share their projects. Thank you so much. It is a mess in progress, the best mess. We will see everybody on Ask an Engineer in just a few minutes, and see you next week. Bye-bye.